All right, so absolute value inequalities. First, let's take a look at why do absolute value equations have more than one value. So if we have absolute value of x equals 4, there's two values that could make this true. If x was negative 4, that would be 4. And if x was positive 4, it would be 4. So this has two true solutions. So that's why when we're doing these, we have to consider the positive end and the negative end. So for this one, absolute value of x minus 3 is less than or equal to 5. So we could set this up as x minus 3 is less than or equal to 5. But then on the other side, it could also be negative 5. When we're thinking of the negative 5, the sign has to change. And the way we deal with that is we just do it like this. So again, let's see what that looked like. We copy down what's here, and then we just put the sign like that and put the negative 5. And now we're thinking of this value is less than or equal to 5, or it's greater than or equal to negative 5. All right, now we just have to solve for x. So from here, we're going to add 3. So we have negative 2, x, and 8. All right, so x has to be between negative 2 and 8. So if I put 0 right here, 1, 2, 3, 4, 5, 6, 7, 8, and negative 2 would be here. Are we going to have open circles or closed circles? Closed, because we have that equals part right there. So this is the solution set, everything between and including negative 2 and 8. And we could check and make sure that that solution set seems like it works for us. So let's choose a value in there, and 0 is very easy to plug in for us. So let's try to plug in 0 for the original equation and see if we get a true statement. So absolute value of negative 3 is less than or equal to 5. 3 is less than or equal to 5. That's true. So that doesn't guarantee that this is right, but that's just saying that, all right, it looks like it could be right. All right, this one's a little bit different. If you notice, we have something outside of the absolute value sign here. So before we deal with having the positive solutions and the negative solutions, we have to first get the absolute value by itself on one side. So we'll divide both sides by 2. So now we have absolute value of x minus 1 is less than or equal to, oops, not equal, just less than 5. All right, so now because the absolute value sign is by itself, only the things that are inside it are on the side with it, we can set it up as x minus 1 is less than 5. And on this side, we're going to do negative 5. And now we can try to solve for that. So we'll add 1. So we have negative 4, x, 6. All right, so x has to be between negative 4 and 6. So if we do 0 here, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right, and closed circles or open circles? Open, because we don't have the equals parts there. All right, so everything between negative 4 and 6. And if we wanted to choose a test point, we could choose 0, because it's in there. So 2 times the absolute value of 0 minus 1 is less than 10. 2 absolute value of negative 1, less than 10. So 2 times 1 is less than 10. 2 is less than 10. That's true. So for this one, now it's just a little bit more involved, but same idea. So we have to try to get this whole thing by itself. So we have to get rid of the negative 14 and the 6. So we have 6 times the absolute value of 2x plus 9 minus 14 is less than or equal to 16. All right, so the first thing we get rid of is anything that's not stuck to the variable. So first we're going to get rid of that 14. So we'll add 14. 6 times the absolute value of 2x plus 9 is less than or equal to 30. Now we can get rid of that 6. So we have absolute value of 2x plus 9 less than or equal to 5. All right, so now the absolute value sign is by itself. So now we can go ahead and set up our equation to try to solve this. So we have 2x plus 9 is less than or equal to 5, and then on this side we're going to have negative 5. So take away 9. So we have negative 14, 2x. Oh, I have to remember that equal sign. And negative 4. Now we will divide everybody by 2. So we have negative 7x, negative 2. So x has to be between negative 2 and negative 7. So if I make this 0, negative 1, negative 2, 3, 4, 5, 6, 7. And they're going to be closed circles. We can't choose, well, we could choose 0 and see if it doesn't work because it's outside of our solution set. But if we want to choose something in our solution set, maybe I'll just choose negative 2. So 6 times 2 times negative 2 plus 9. So the absolute value of that, take away 14 is less than or equal to 16. All right, so 6 times the absolute value of negative 4 plus 9 minus 14 is less than or equal to 16. 6 times the absolute value of 5 minus 14 is less than or equal to 16. 30 minus 14 is less than or equal to 16. 16 is less than or equal to 16, and that's true. All right, so for this next set, I'm going to get to the next slide, and then I'm going to ask you to pause it and try to work it out. And then if you get the answer right, you don't have to watch the solution. And if you get the answer wrong, watch as I work out the solution. And I'm not going to do all the words. I'm not going to explain. I'm just going to show it so it goes a little quicker. So those were the examples. Now I'm going to give you some practice problems. So pause it, try it, see if you got it right. If you got it right, you don't have to watch it. If you got it wrong, watch it. All right, one thing to remember is that if you have to multiply or divide by a negative number, it didn't come up in these, but just remember, if you multiply or divide by a negative, you have to flip the sign when you do that.